All right, let's look at the homework 8, problem number 3. All right, so we have this rational function f of x equals x plus 5 over x minus 5. All right, so we want to find the domain. As you can see, when x equals 5, denominator becomes 0. So we have to eliminate 5, but everything but 5 would be fine. So it's all real number x except for x equals 5. So D is the right answer. All right, so let's check the answer. We got that. All right, so next part, intercepts. All right, so let's find the x-intercepts and the y-intercept. All right, so it's gonna here. All right, so let's find the x-intercept. So in order to find the x-intercept, right, what you need to do is you need to set the other one. So it's a y equals 0. In this case, is the function. So it's going to be, right, so we have f of x is 0. And you have x plus 5 over x minus 5, right? Then we know that in order to make the fraction equal to 0, we have to make sure that the numerator, which is x plus 5, has to be 0. All right, then we can just move 5 over to the other side. We can do that by subtracting 5 from both sides. So you have x is equal to negative 5. So that's the x-intercept. All right, y-intercept. All right, so in order to find a y-intercept, all you have to do is set the other guy, so in this case x, equals 0. All right, so y is going to be simply plug in 0. So it's at 0 plus 5 over 0 minus 5. Right? 5 divided by negative 5 would be negative 1. So y-intercept is negative 1. Right? So let's type it in. All right, so x-intercept is negative, what was it, the negative 5, and y-intercept is negative 1. So negative 5, so now this one, negative 5, negative 1. So D is the right answer again. All right, let's check the answer. All right, we got that. All right, we want to find the horizontal asymptote and the vertical asymptote. All right, so let's do that. To find the horizontal asymptote, since it's a rational function, we can do this. You can look for the highest power on top, which is going to be 1. So the degree on top is 1, and degree on the bottom is also 1. So when the degree on top and the bottom are the same, we look at the leading coefficient. Leading coefficient on top is 1, and the leading coefficient on the bottom is 1 as well. So y equals 1 over 1, which is y equals 1. So horizontal asymptote is y equals 1. All right? So vertical asymptote, we set the denominator equal to 0, so you can see that the vertical asymptote is x equals 5. So it's a vertical line at x equals 5. All right, so let's check the answer. Let's type it in. All right, horizontal asymptote is 1, and the vertical asymptote is positive 5. So it's going to be B. All right, let's check the answer. All right, got that. All right, then we want to find, let's see, we want to look at the increasing, decreasing behavior by looking at the first derivative. All right, so let's take the first derivative. All right, so f prime of x is equal to, all right, so we're going to use the quotient rule. So square the bottom. So you have x minus 5 quantity squared. All right, derivative of the top is 1. Times the bottom is x minus 5 minus top, which is x plus 5, times the derivative of the bottom, which is 1 anyway. All right, so 1 really doesn't do anything, so I'm going to scratch that so that you don't have to look at it. So you have x minus x, you can cancel those. Right, so you can see that this cleans out to be negative 5 minus 5, so it's going to be negative 10 over quantity x minus 5 squared. Right, so you can see that this quantity is always negative, which means that so this means that the original function is always decreasing, right? So except for x equals 5, so you have to eliminate that, all right? But let's find the answer, all right? So it's going to be decreasing, let's see, we have to eliminate 5, right? So it's decreasing on negative infinity to 5 and 5 to infinity. So D is the right answer, all right? We got that. Right, what's next? So we want to find the local minimum or local maximum. Right. So we look at the first derivative and we realize that this function is always decreasing, which means that there'll be no local maximum or local minimum. Right, because you don't have a hill or valley, so we don't have so there is no local extrema because it's constantly decreasing, right? So let's check the answer. All right, we got that. All right, next one is a concavity. So in order to discuss concavity, we have to take another derivative. All right, so easiest way to take the derivative would be, so I'm going to rewrite this first derivative as negative 10 quantity x minus 5 to the negative 2 power, right? Then I'm going to use the general power rule to find the second derivative, all right? So we have negative 10, so put that out there, all right? Derivative of that would be put negative 2 in front, and you have a x minus 5, and subtract 1 from the power, negative 3, and then multiply by a derivative inside, which is going to be 1, which really doesn't do anything. So this can be simplified as negative 10 times negative 2 is 20. I put it up there, right? So quantity x minus 5 will be sitting downstairs because of the negative power, and you have to cube it, right? So let's do a number line here. So draw a number line. All right, and then you have x. So tick marks would be x equals 5 because the function is not defined there. So I'm going to put 5 there. All right, let's look at the sign of the second derivative. All right, so any sample number less than 5, so I'm going to try 0. All right, so you can see that if you plug in 0 into the second derivative, all right, negative 5 cubed is negative. Positive divided by negative is going to be negative. Right? And we're going to try something bigger than 5. So I'm going to try 6. If you plug in 6 minus 5 is positive, everyone's positive. So second derivative is positive. Right? So we have a concavity is going to be concave downward before 5 and concave upward after 5. All right, so let's choose the answer. All right, concave down on negative infinity to 5, concave upward. So that's exactly what we said, right? Concave down to concave up. All right, so you have that. Let's check the answer. All right, we got that. All right, and we want to find the inflection point. All right, so you can see that even though there's a concavity change, the only problem is at this point, function is not defined. So there is no inflection point there. So here, no inflection point. All right, so check that. All right, we got that. All right, so we have to find a picture. All right, so it's a picture always decreasing. So here A is always decreasing, B is eliminated, increasing. So C is decreasing, and D is increasing. So D is eliminated. So it's going to be between A and C. Right. So let's look at the location of the vertical asymptote. What did we say about the vertical asymptote we looked at? We have a vertical asymptote at positive 5. All right, so let's look at this. That's going to be at positive 5. This one is at negative 5, so C is the correct picture. All right, let's check the answer. We got that. All right, that's it. I hope that this was clear.